So in the early 90s, when we first started the company, we observed that in a software program, inside it, there are just a few lines of code, maybe 10% of the code does 99% of the processing. And that 99% of the processing could be done in parallel. However, the other 90% of the code has to be done sequentially. It turns out that the proper computer, the perfect computer, is one that could do sequential processing and parallel processing, not just one or the other. That was the big observation. And we set out to build a company to solve computer problems that normal computers can't. And that's really the beginning of NVIDIA.
I've heard you say that GPUs were a time machine.
Yeah.
Could you tell me more about what you meant by that?
A GPU is like a time machine because it lets you see the future sooner. One of the most amazing things anybody's ever said to me was a quantum chemistry scientist. He said, Jensen, because of NVIDIA's work, I can do my life's work in my lifetime. That's time travel. He was able to do something that was beyond his lifetime, within his lifetime. And that's because we make applications run so much faster. And you get to see the future. Partly researchers discovering it, partly internal inspiration, and partly solving a problem. And a lot of interesting ideas come out of that soup. Some of it is aspiration and inspiration. Some of it is just desperation. And so in the case of CUDA, it was very much the same way. And probably the first external ideas of using our GPUs for parallel processing emerged out of some interesting work in medical imaging. A couple of researchers at Mass General were using it to do CT reconstruction. They were using our graphics processors for that reason, and it inspired us. Meanwhile, the problem that we're trying to solve inside our company has to do with the fact that when you're trying to create these virtual worlds for video games, you would like it to be beautiful, but also dynamic. Water should flow like water, and explosions should be like explosions. So there's particle physics you want to do, fluid dynamics you want to do, and that is much harder to do if your pipeline is only able to do computer graphics. And so we have a natural reason to want to do it in the market that we were serving. So researchers were also horsing around with using our GPUs for general purpose acceleration. And so there are multiple factors that were coming together in that soup. When the time came, and we decided to do something proper and create a CUDA as a result of that. But the big breakthrough, I would say, is when we saw AlexNet, we asked ourselves, how far can AlexNet go? If it can do this with computer vision, how far can it go? And if it could go to the limits of what we think it could go, the type of problems it could solve, what would it mean for the computer industry, and what would it mean for the computer architecture? And we rightfully reasoned that if machine learning, if these deep learning architecture can scale, the vast majority of machine learning problems could be represented with deep neural networks. And the type of problems we could solve with machine learning is so vast that it has the potential of reshaping the computer industry altogether, and which prompted us to re-engineer the entire computing stack, which is where DGX came from, and this little baby DGX sitting here. All of this came from that observation that we ought to reinvent the entire computing stack layer by layer by layer. Computers, after 65 years since IBM System 360 introduced modern general purpose computing, we've reinvented computing as we know it. There's, of course, very difficult times along the way. When you're investing in something and nobody else believes in it and costs a lot of money, and maybe investors or others would rather you just keep the profit, or whatever it is, improve the share price or whatever it is. But you have to believe in your future. You have to invest in yourself, and we believed it so deeply that we invested tens of billions of dollars before it really happened. And yeah, it was 10 long years, but it was fun along the way. The first core belief was our first discussion was about accelerated computing, parallel computing versus general purpose computing. We would add two of those processors together, and we would do accelerated computing. And I continue to believe that today. The second was the recognition that these deep learning networks, these DNNs that came to the public during 2012, these deep neural networks have the ability to learn patterns and relationships from a whole bunch of different types of data, and that it can learn more and more nuanced features if it could be larger and larger. And it's easier to make them larger and larger, just make them deeper and deeper, or wider and wider. And so the scalability of the architecture is empirically true. The fact that model size and the data size being larger and larger can learn more knowledge is also true, empirically true. And so if that's the case, you could, what are the limits? There's not, unless there's a physical limit or an architectural limit or a mathematical limit, and it was never found. And so we believe that you could scale it. Everything that moves will be robotic someday, and it will be soon. The idea that we'll be pushing around a lawnmower is already kind of silly. Maybe people do it because it's fun, but there's no need to. And every car is going to be robotic. Humanoid robots, the technology necessary to make it possible is just around the corner. And so everything that moves will be robotic. And they'll learn how to be a robot in Omniverse Cosmos, and will generate all these physically plausible futures, and the robots will learn from them, and then they'll come into the physical world, and it's exactly the same. A future where you're just surrounded by robots is for certain, and I'm just excited about having my own R2D2. Well, there's a whole bunch of the stuff that everybody talks about, bias or toxicity or just hallucination. Speaking with great confidence about something it knows nothing about, and as a result, we rely on that information. Generating, that's a version of generating fake information, fake news or fake images or whatever it is. Of course, impersonation. It does such a good job pretending to be a human. It could do an incredibly good job pretending to be a specific human. And so the spectrum of areas that we have to be concerned about is fairly clear, and there's a lot of people who are working on it. There's some of the stuff related to AI safety requires deep research and deep engineering, and that's simply it wants to do the right thing, it just didn't perform it right, and as a result hurt somebody. For example, a self-driving car that wants to drive nicely and drive properly, and just somehow the sensor broke down, or it didn't detect something, or made it too aggressive turn, or whatever it is. It did it poorly. It did it wrongly, and so that's a whole bunch of engineering that has to be done to make sure that AI safety is upheld by making sure that the product functioned properly. So suppose now everybody is surrounded by these super AIs that are very good at specific things, or good at some of the things. What would that make you feel? Well, it's going to empower you. It's going to make you feel confident. And I'm pretty sure you probably use ChatGPT and AI, and I feel more empowered today, more confident to learn something today. The knowledge of almost any particular field, the barriers to that understanding it has been reduced. I have a personal tutor with me all of the time, and so I think that feeling should be universal. And if there's one thing that I would encourage everybody to do, is to go get yourself an AI tutor right away. And that AI tutor could, of course, just teach you things, anything you like, help you program, help you write, help you analyze, help you think, help you reason. All of those things is going to really make you feel empowered. And I think that's going to be our future. We're going to become superhumans, not because we're going to become superhumans because we have super AIs.